Alright, we're at section 9.3.5, which are irrational and imaginary roots. And first thing it says is using only integers for a, and just by looking at the polynomial expression, list all the possible linear factors, x plus or minus a, for the polynomial p of x equals 4x to the fourth, x to the fourth minus x to the third minus 5x squared plus 3x plus 6. So remember, that's doing our p's divided by our q's. So our p is the sign of the constant, or is the constant, p is the constant, which is 6. And then we write our factors of 6 out. So 1 and 6, 2 and 3. Q is our leading coefficient, which happens to be a 1, and the only factor of 1 is 1. So as we go and do our p's divided by our q's, then we would have plus or minus 1 divided by 1 is 1, plus or minus 2, 3 divided by 1 is 3, plus or minus 3, and plus or minus 6. Now those are your possible roots. This problem actually says the possible factors. So the possible factors would be x plus 1 and x minus 1, x plus 2 and x minus 2, x plus 3, x minus 3, and x plus 6, and x minus 6. And remember, like x plus 1 would actually have the root or 0 of negative 1, because you have to set that equal to 0. All right, now it says, could x minus 5 be included on your list of possible linear factors? Well, if we look here, it's not on our list, so no. And the reason being because 5 is not a factor. Of 6. Remember, we got these by doing the p's divided by q's, and the p is 6. 5 is not a factor of 6. So it's not possible to have that as a factor. All right, so it says not all of the possibilities will be factors. Use a graphing calculator to decide which possible roots on your list are the best possibilities. So we're going to type this in here. I'll go back to a standard window. And so again, the best way to do this is to look at the table. And I see that 2 has a y value of 0. So 2 is definitely going to work, positive 2, and that is in our list. Okay. And we can see if there's any others in here. Negative 1 also would be. But we can see it's crossing at more places than just that. So this is kind of why we've been doing it the way we have. But we can see that there's definitely 2 linear factors, negative 1 and 2. So I'll write that here, x equals negative 1 and x equals 2. Now that you have shortened your list of possibilities, which factors on the shortened list are actually factors? Use synthetic division to divide p of x by one of the factors. Write the polynomial as a product of a linear and a cubic factor then. So I'm going to do the 2 first. And so my coefficients are 1, negative 1, negative 5, 3, and 6. Bring down my 1. 1 times 2 is 2. Negative 1 plus 2 is 1. 1 times 2 is 2. Negative 5 plus 2 is negative 3. Negative 3 times 2 is negative 6. 3 minus 6 is negative 3. And negative 3 times 2 is negative 6. And when I add 6 minus 6, that gives me that remainder of 0. So the first thing I would write down is p of x equals the factor. Since my root is 2, my factor would be x minus 2. And then I would be left with, again, I started out with x to the fourth. And then I divided that by some x, so this would be x to the third plus x squared minus 3x, and then minus 3. So that's what I have so far. And now we're going to go one more step further because I still can't factor this without just using my normal factoring methods. So it says now divide the cubic factor by the other linear factor that works. So we already did the 2, so now we're going to do the -1. And then write the polynomial as a product of 2 linear factors and 1 quadratic factor. All right, so now I'm going to put -1 here. And again, I'm using the coefficients for this cubic one now. So 1, 1, -3, -3. So bring the 1 down. 1 times -1 is -1. 1 minus 1 is 0. 0 times -1 is 0. -3 plus 0 is -3. -3 times -1 is +3. -3 plus 3 is 0, so we know that works. And so now I'm going to write this as p of x equals, the first factor was x minus 2. I then had a root of -1, so that'd be a factor of x plus 1. And then I would be left with x squared, there's no x's, minus 3. So x squared minus 3. And I can't factor x squared minus 3, so that would be my factored form. And it says, next step says, now that it is factored, you can find the exact x-intercepts for the polynomials. What are those roots? So remember, anytime we're finding zeros or roots or x-intercepts, we're setting each factor. We'd set the y, in this case p of x, equal to 0. And since it is already factored, what we need to then do is set each factor equal to 0. So if I set x minus 2 equal to 0, so I'd have x equals 2. X plus 1 equals 0, so I get x equals -1. And then the last one, x squared minus 3 equals 0, so I'd add 3 and get x squared equals 3. And I had to undo the square by taking the square root. So I get x equals plus or minus the square root of 3. So my 3 roots are x equals 2, x equals -1, and x equals plus or minus the square root of 3. So there's 4 different ones there. Notice these are rational, and these then would be irrational, which we couldn't really get off the table.